We are moving on to our last exponent trick. So we have learned a lot. We've learned negative exponents. We've learned zero exponents. I'm going to write that down. We've learned negative. We've learned zero. We've learned the product of powers, meaning x squared times x cubed, which means 2x's and 3x's is x to the fifth. We've learned power to a power property. Power to power. And that was, if we had x squared 3 times, it would be 2x's and 2x's and 2x's, which would be x to the 6th. That is multiplying. And now we're going to learn the last one, which is the division property of exponents. So that you have to know how to apply all of those tricks. Okay, so let's apply this and let's connect this to 7th grade standard. If I have x cubed over x squared, that means on the top I have 3 x's. And on the bottom, how many x's do I have? 2. And I can simplify because if you have a number or a variable over itself, it turns to 1, right? 4 over 4 just kind of cancels out and turns to 1. Same thing with variables. It would cancel, cancel, I'd be left with an x. A to the 4th b cubed over ab squared. That means I'd have 4 a's, 1, 2, 3, and 4. 3 b's, 1, 2, 3, all over an a and 2 b's. And you can cross off what's shared. 1 a would be crossed off, and 2 b's would be crossed off. I would be left with a cubed b. Now you are not expected as 8th graders. This is how we do it as 7th graders. We expand and cross off. As 8th graders, you can actually apply the property. The property, if you notice, you just subtract what they share. So if I have 4 a's and I have an a on the bottom, they share 1 a, so I would take one of the a's away. If I have 3 b's on top and 2 on the bottom, they share 2, so I would take 2 of them away. That brings us to the division property of exponents, which states a to the n over a to the m is equal to a to the n minus m, meaning you can just subtract the exponents. But we're going to have to connect this with our zero and negative property, but we never simplify. When I say simplify the exponent, I mean like change any zero exponents and negative ones. You never do that till the last step. You always do product property, power property, and then division property. So let's apply this first one. 4 to the 4th over 4 squared is equal to, they're the same base, so it would be 4 to the 4 minus 2, which is 4 squared, which is 16. Final answer. A cubed b to the 5th over a to the 6th b to the 5th is equal to a to the 3 minus 6, b, oh, is that 5? B to the 5 minus 5, I think that's a 5. 5 minus 5, which is a to the negative 3, b to the 0. And now I can apply those properties that we learned the first day. This needs to move, and this will turn to 1. So I'm left with a 1 on top and an a cubed on the bottom. Final answer. Is there more? Because I want to make sure that you have, because I want to make sure that you have some negative answers in there too. You got to remember your integer rules as well. Oh yeah. Coefficient examples. You to do with this. There's two ways. You can simplify your coefficients at first, meaning I know this is going to be 1/3, and then deal with your exponents, or you can deal with it at the end. Okay? So, I simplified in the beginning. 3/9 is 1/3. You can't subtract anything because it's not a 3/3. They have to be the same base. So this is going to be x to the 2 minus 1. You have to make that 1 come out. Y to the 4 minus 9. Which is x, y to the negative 5. Notice I still have my 1/3. That's what I just wrote there. I still have my 1/3. So on the top I have a 1. On the bottom I have a 3. That's from my coefficients. My x stays with my 1. My y to the negative 5 needs to go on the bottom. And then you just make it look pretty because that doesn't look so pretty. 1 can hide again. X over 3y to the 5th. That's what you do. Exponents are like little puzzles. As long as you just need to remember, when do you add, multiply, subtract, when do you move? That's everything you need to remember. 24/6 is just 4, isn't it? 24/6 is 4. So this would turn to 1, this would turn to 4. And then I figure out my exponents. A to the 3 minus 3, B to the 1 minus 4, C. Now this is what I've been waiting for. Notice you still have to subtract. It's C to the negative 6, take away a negative 8. Turns to plus plus. A to the 0, B to the negative 3, C squared. You see where that came from maybe? Right? Because negative 6 plus 8, that turns to plus plus, is positive 2. And then I just figure out what's going to go on top and what's going to go on bottom. So that's just going to be nothing. This is going to go on the bottom. And then my c squared will stay on top. Don't forget your exponents. Where should I put it? I'll put it up here. So I have a 4 on the top and then a c squared on the top. On the bottom I have a 1. I'm going to go ahead and just let it hide and b cubed. That's that. Little intense with the coefficients. Just know that you could always just, coefficients are just kind of awkward. I mean, they're just kind of left to the side for a minute as you simplify all the variable stuff, and then you just got to bring them back in after you're done with them. Okay, so scientific notation, that's always kind of a connection with all of our properties here. Scientific notation, you'll divide the numbers and then subtract your exponents. And then, of course, make sure it's in proper form. Why didn't I write that down? Third, proper form. Okay. So, here's how we handle that. In my calculating device, also known as a calculator, I will go 32.14 divided by 9. I'm just going to divide the coefficients times 10 to the, now I subtract, 6 minus a negative 5. Well, 32.14 divided by 9 is 3.57. Let's just do that. I'm just going to say 3.571 times 10 to the 11th. Am I in proper form? I am in proper form. You want to know why? Because I have one number to the left of the decimal. I am in proper form. What? What is this?
That looks hard.
It's supposed to be like a you'll never see it looking like this. It's supposed to be a division bar. But it's the same strategy. I would go 4.39 divided by 8.3. And that's ginormous number. Let's just do 0.5289. Times 10 to the -4 minus a -2 is 0.529, 5289, my bad, times 10 to the -2. And it's not in proper form. I didn't get it in proper form. So this is going to turn to 5.289 times 10. So I made it bigger by 1. I'm going to make it smaller by 1, -3. And that is a division property of exponents.